Okay, guys, so this homework is on Go Formative and it's also in your books. So, but I'm going to give you all the answers on how to work it out. The best idea will be always to try by yourself and then look for help. So, you're going to look for homework help online from your textbook, or you can watch this video. So, yeah, we have all the alphabet and we need to the O by accident. I don't know if that's on your paper too. I mean, on the in Go Formative, the O end up over here, but I just put it back here. Okay. We need to find all the letters that has a reflection symmetry and all the letters that has rotation symmetry and the one they share it. So if you look at reflection symmetry, so A, if I put a line in the middle, that's going to have a reflection. B, if I put a line in the middle here, it's going to have a reflection symmetry. C, the line in the middle. D, the line in the middle. E also has a line here, a line of symmetry. M, it's going to be vertical line. T, I can put a line right. It's going to go through the bottom of letter T. U also, see the U that they're using doesn't have the little piece at the end. That's why it's symmetrical. V, line in the middle. W, line in the middle. Also, Y, my Y does not seem like it has a reflection symmetry, but if you look at this Y, if we put a line in the middle, it has a reflection symmetry. Now, rotation symmetry. N has a rotation symmetry. If I rotate it 180 degrees, it's going to end up on itself. S, 180 degrees. And Z is also 180 degrees. Now, the one they have both is H, 180 degree rotation, and also you can have actually two reflection symmetries. I has two reflection symmetry and 180 rotation. O is has multiple reflection symmetries, but also rotation, and it's really every single angle if you rotate O. X, reflection symmetry, two of them. Rotation, I think there's 190 degrees and also 180. So they belong to both of them. They have reflection and rotation. Now F, G, J, K, L, P, Q, and R do not belong to any of the sets. The problem can be K. Y does not have a reflection symmetry. I guess you could probably argue that it can have a reflection symmetry here, but this picture is not exactly the same. So the bottom of the K would not cover the top. So I would put the K outside. And that's problem 1-4 from the homework. Okay, the next problem is a little bit more complicated because you have a lot of steps. You have 2 points. You have to calculate the slope and then write equation of the line. So it will be a little bit helpful to graph it. I know there's a lot of stuff over here on this picture, so let me go over this. So first thing what I did is I plot the points. This is point -1, 1, and this is 0.41. I drew the line, and then I tried to figure out the slope. So they gave you a formula for slope, and let's use the formula first. The formula I use using y2, y1, x2, x1. Where is this coming from? Where every point has x value and y value and x value and y value. And since they're not the same, I can call this x1, y1 because it's at one place. And this is going to be x2, y2. So now I'm using those to plug into my equation. So if I would choose y2, that's 5 minus y1, that's 1. So 5 minus 1. And then x2 is 4 minus, and then x1 is -1. So I would have double negative. which actually will turn to plus. So my slope will be 4 over 5. Slope is a ratio, so we don't want to really change it into decimal. So you can keep it as that, 4 over 5. Now there's another way of finding the slope if you have a picture. You can go from first point to the second point, and if you remember, slope is rise over run, which means you would first go up or down, and then we're going right or left, usually right. So if I would go up from this point to this point, not going straight to it, but using just a grid, I would go 4 points up and then 5 points to the right. 4 points up, that means positive 4. 5 points to the right, that means positive 5. So that again, the slope is 4 over 5. Now, equation of the line, and I know you guys did it last year, but it's probably forgotten. We're going to have a whole lesson on this again. There is an equation for a line if you have 2 points given, or 1 point given in the slope. So equation for that is y minus y1 equals m times x minus x1. So m means slope. So I'm substituting. Which point I'm using? Well, since I marked this point x1, y1 already, I'm just going to use that. So y minus 1, because y1 is 1, equals my slope that I just found, 4 over 5. And x, it will be minus negative 1, but because I have two minuses, I'm going to make it into plus. Okay, next step is to distribute. So 4 over 5 times x is 4 over 5x, and 4 over 5 times 1 is 4 over 5. We're solving it for y, because the equation of the line, if you guys remember, are usually in this form, mx plus b. So everything except y is on right side, and this is y equals. So I'm going to add 1 to both sides so they cancel. And I'm adding 1 to 4 over 5 because that's the only one that doesn't have x. Okay, representing y as a fraction, I can say 1 is 5 over 5. Okay, so I'm really adding to 4 over 5, I'm adding 5 over 5. If you remember adding fractions, oops, that's supposed to be 5. You keep your denominator the same, but you're just adding the numerator. So 4 plus 5 is 9, and we keep denominator since it's the same. So equation of the line is y equals 4 over 5x plus 9 over 5. Okay, the next part of this problem is to find the distance. Again, there's two ways of finding this. There's a nice long formula that everybody forgets, and there's a visual way. But let's use the formula. Again, they're using x2, x1, y2, y1. So I'm going back to the points the way I marked them, and I'm using it exactly what the way the formula is telling me. So x2 is 4 minus from the formula, x1 is negative 1, and then I have to take everything and square it. And then I'm adding, and it's y2 is 5 minus y1 is 1, and then everything squared. Okay, parentheses first. So 4 minus negative 1 already means 4 plus 1. That's 5. And then still squared. And then 5 minus 1 is 4. 4 squared. And then it takes us to the next step. 25. How I get 25? Well, 5 squared is 25. 4 squared is 16. I'm adding them. That is square root of 41 because we had the square root following us since the beginning. And we do everything inside first, and then you can take a square root. So if you put in a calculator, square root of 41 is approximately 6.4. That's the one way using the formula. The second way is a little bit more visual and probably something you would not forget, like the formula. If you have a right triangle, because that's what we have here. I kind of made a right triangle out of this. And this side is 5, this side is 4, and this side is missing. So that's something that should remind you of A, B, and C, and this nice formula that you know from middle school. Actually, the distance formula comes straight from here by doing some operation, but this is a lot easier to remember than all this piece. So how do I use it? I know this distance is 5, and I know this distance is 4, because this is 5 units away and 4 units away to create my right triangle. So my A will be 5, my B will be 4, and my C is what I'm looking for, right? So 5 squared is 25, 4 squared is 16, and I'm still looking for X. Just like we had it here, it's almost the same thing, except this one is using square root right away, and we're going to square root at the end. So 25 plus 16 is 41, and that's X squared. So that's not my answer. If I square root both sides, I'm going to get exactly what I got from the formula. So 2 ways of doing this. Okay, the next part is to explain what is the difference between part A and part B. Well, part A is finding the slope, and the slope is really a ratio. And part B is asking to find the distance, and the distance is a length. So that's the only difference here. Okay, moving on to the next problem. Oops. They're asking you which triangle has only one line of symmetry. So if you go back to your notes, or the notes that are online, the triangle with one line of symmetry is the isosceles triangle. It has a line of symmetry there. Triangle with 3 lines of symmetry. Well, that means I can put a line here, and line here, and that is only equilateral triangle. That's the only one that has 3 lines of symmetry. So quadrilateral with no lines of symmetry, but it have rotation symmetry. So if I put a line of symmetry here, it's not going to match on the other side. So it doesn't have a reflection symmetry, but it has a rotation of 180, and that's parallelogram. All right. Next one is to solve proportions. They're called equations here, but those are really proportions. And the way you solve proportion is by cross multiplying. So x times 4, and then equals a times 3. That's 24. And to get x by itself, you want to undo the multiplication by dividing by both sides, and x is 6. Same idea. 2 times 40 is 80, and x times 5 is 5x. Now, it doesn't matter which way you're going to write it. You can write 80 equals 5x or 5x equals 80. It does not matter what side is your x on. Divide both sides by 5, because that would cancel, and x is 16. 80 divided by 5 is 16. Okay, a times x, I put it right here, and 1 times 12 is 12. Divide everything by 8. So you always divide by the number in front of x. And 12 divided by 8 is 1.5. X times 15, 15x. 10 times 120, 10 times 12 is 120. Divide both sides by 15. Everything equals to 8, because 120 divided by 15 is 8. Okay, and the last problem here is those homeworks, guys, they're kind of going ahead. of what we're doing because that's how they usually work. It's called review preview. So some of them you should know, some of them is new, but we're still going to talk about it. So let me explain this problem. You want to find area and perimeter. Area means multiplying size, and perimeter means going around the whole thing. So in order to find area of something like this, I would divide it into two different areas. What I see here is this rectangle right here and the one over here. Now, could you divide it the other way? Yes, it's okay. That's the first thing I saw. That's why I did it. So area of rectangle is uh, base times height, or A times B, so side times side, right? And I'm going to first find area of the first one, then area of the second one. In order to get the total area, I'm going to just add both of the areas. So I have one of the sides given. The only problem is I really didn't have this side. They didn't give it to me at the beginning. But since I know the whole thing is 16, and this piece right here is 9, okay? So 9 plus what is 16? Or the other way around, 16 minus 9 will give you the piece over here, just the side of this small rectangle. And it's turned out to be 7. So my area will be 6 times 7, which is 42. That's just the area of the top rectangle. And then I'm looking at the bottom rectangle right here. I know the base is 21 and I know the side is 9. So 9 times 21 is 189. So if I add them together, it's 231 centimeters square. Every area always have units square at the end because you're finding how many squares can you put inside of this. Perimeter is going around, so you can start any place you want. Let's say I'm going to start here. So first I'm going to walk 6 centimeters. That's what I put here. Then I'm going to turn around and walk 7. Then I'm going to walk this distance, and I didn't know that until I took 21, so the whole length, minus the 6 that was on the top. So that would give me 15. So this whole thing was 15. And then I walked 9. And then I walked the whole 21. And then I have all this length to be 16, so I'm just going to use 16. And then I start adding it all together, and that gave me 74 centimeters. This does not come in a square because it's a length. You don't walk in squares, you just walk straight lines. So that is units. Units are the same as the units given to you. And that is for everything for homework 1. Hopefully this was helpful. Let me know if you have any questions.